Okay, good morning, good afternoon, everyone, and thank you for joining us today for this webinar brought to you by the International Radiation Association. For those of you who are not familiar with the association, the IIA, we're an NGO, we're a trade association that supports and promotes the safe and beneficial applications of irradiation. We're technology neutral, so we support gamma, E-beam, and X-ray technology. And today, of course, we're going to be focused very much on gamma. Um, we are also a not-for-profit, so anything that we do, including this webinar, is supported by membership. So if you're involved in irradiation or radiation processing and you'd like to be perhaps more engaged or demonstrate your engagement and your commitment to irradiation, then we'd love to talk to you about membership. There's lots more information on our website. The address is iiaglobal.com, and we'll be sharing that at the end of the webinar. Yeah, we look forward to hearing from you. So today we're going to be talking about various initiatives that have either recently been completed or are ongoing to secure the long-term supply of Cobalt-60. And as many of you know, Cobalt-60 is a critical part of the gamma irradiation supply chain. And of course, gamma is responsible for sterilizing approximately 1 in 3, in some regions, more than 1 in 3 single-use medical devices. So if you've ever been to a doctor and you've had, for example, a blood sample taken, or if you've had surgery at hospital, or you've had a wound treated, then it's highly likely that you've already benefited from gamma radiation. What's a little bit different today, about the webinar today is that we're going to hear from the Cobalt-60 producers. So the operators that produce the Cobalt-60 in reactors, rather than the manufacturers of the finished sealed sources that are supplied to the radiation processing industry. So we have 4 speakers today. We have Chad MacLean from Bruce Power, and we have Kris Horne from Ontario Power Generation, OPG. And Bruce and OPG are 2 important existing producers of Cobalt-60, and we'll be receiving an update from both of them. Our third presenter is Kris Paserba from Westinghouse, and Kris and his colleagues at Westinghouse have been, along with partners, have been developing Cobalt-60 production in a different reactor platform in the US. So exciting to hear about the progress that they've made. And then our final presenter today is going to be Richard Wiens from Nordion, and he's going to be talking about the impact of all of these initiatives and some of the other work that Nordion has been doing over recent years to secure that supply chain. So before we start with our first presentation from Chad, just 2 pieces of housekeeping. Firstly, this webinar is being recorded and it will be made available via the website, via the IIA, before the end of today. And secondly, for presenters, your microphones and your cameras are switched off. So if you have any questions, then please enter them into the Q&A tab, which you'll see at the top of the screen, and we'll get to those at the end of the presentations today. So without further ado, we'll make a start with the presentations. And our first presenter I'd like to introduce is Chad MacLean of Bruce Power. Chad is Senior Director of Business Development and Transformation at Bruce, and he's going to be updating on their recent work around isotope production, ongoing reactor refurbishments, and some future opportunities going forward. So Chad, we look forward to hearing from you. I'll hand over to you. Thank you.
Great, Martin. Thanks very much. And just before I get started, can I just get confirmation you can see the screen?
Yes, we can.
Perfect. Okay, great. And hi, everybody. Yeah, so as Martin mentioned, my name's Chad MacLean. I'm the Senior Director for Business Development at Bruce Power. And I have the opportunity to work in the areas where we look at our, what we call our nuclear expansion strategy. So that's how we're refurbishing our units, which I'll touch on today, the exciting opportunity that we have in front of us for a potential new build. So the first of a kind in the province for quite some time for large reactors on our site, and then also our medical isotope program. So what I wanted to cover today was just a little bit about Bruce Power, who we are and what we do, how we're building for the future, not only for electricity supply in Canada, but how that medical isotope program has become an integral part of what we do and what our future strategy is, bolstered on the cobalt production we've had for the past few decades on site and the strong relationship that we do have with Nordion. And then also how as an industry we're working together, not only from an electricity perspective as generators, but how you'll see the folks on this call working together as an industry to meet the demands for the medical isotope industry, particularly with cobalt supply, and really the demand of who matters most. Martin mentioned sterilization of equipment. When we look at the importance of supply of medical isotopes, it's really getting that equipment and that isotopes into the hands of the people that matter most, being either the frontline workers or the patients who benefit from those treatments. So although Bruce Power has been producing electricity for decades and cobalt for decades, the importance of medical isotopes in our strategy and what we look to provide to the province has continued to grow, and it maintains a priority for us. So just a little bit about Bruce Power. For those that don't know, we are a private electricity generator in Ontario. We're located about 2 hours northwest of Toronto in a town called Tiverton. And we have 8 CANDU reactors on our site. So for reference, when I talk through our cobalt production particularly, we have 2 stations with 4 reactors in each. One's referred to as Bruce A, one referred to as Bruce B. And those 8 CANDU reactors generate about 6,300 megawatts of power. And to put that in perspective, that's about 1/3 of Ontario's energy is provided by the Bruce Power site. We have been producing power as Bruce Power since the early 2000s. And I'll talk a little bit more detail later on, but recently have entered into what we call our major component refurbishment program. And the outcome of that program is ultimately that we can extend the life of our units by about 35 years per unit that's being refurbished. But that bigger picture puts Bruce Power's end of life out to 2060. So we're operating 8 units now and expect to be operating 8 units out to the 2060s as a result of this life extension program. And then finally, as we get later on in the presentation, I will talk about the exciting opportunity for Bruce C that we have, which is our new build project, but also tie that back to not only how we plan to bolster the supply of cobalt through our refurbishments, but potentially add to that supply with the Bruce C station and what those reactors and technology evaluation process looks like for us. Now, one of the things at Bruce Power that we're proud of being in a rural area is the impact on our local communities and what we call our Canadian at our core campaign. So I mentioned we have the 8 reactors on site, produce about 6,300 megawatts of power annually. But we really focus on keeping that spend and the revenue and the income generation focused on Canada, and that's our Canadian at the Core campaign. So I just wanted to touch on a couple key highlights to that perspective, that priority, and that focus as we talk about things like medical isotope production and how Canada has really positioned itself as a leader in the space, and how we can continue to drive that leadership position is really focusing what we call on the Canadian at our core. So as a result of the operation of our units, actually 95% of our spending stays in Canada, which results in a local impact of about 3 million annually on our local communities. And in addition to things like the partnerships that we have with our local Indigenous communities on things like isotope production and what we call reconciliation through action, we're also focused heavily on how we continue to work with like the CNIC, Nordion, and other partners to continue to drive for some ambitious goals to double medical isotope production by 2030, and how that can tie into our long-term refurbishment strategies as a site. So in addition to producing 8 units of power as a nuclear energy generator, which is our primary business and our core focus, a backbone to our strategy and a backbone to priorities is our medical isotope program. So Bruce Power currently produces 2 isotopes, Cobalt-60 and Lutetium-177. Cobalt-60, which we'll spend the majority of the time talking about today. However, I will cover a little bit about our Lutetium-177 production, because it has really changed what Bruce Power is considering and is able to do in the medical isotope production space, and helps us to continue to drive the value add that we see through our contribution to the medical isotope ecosystem. So we have been producing cobalt on site since 1986. And we began producing lutetium in 2022. And we really focus as Bruce Power as the role of an irradiator. So we've been able to talk through our cobalt program in a minute, but we've been really able to position ourselves to successfully and safely create Cobalt-60 through use of the neutrons that we derive out of our reactor process. and then determined a way to do that online with lutetium-177. So one of the things that I think is important when we look at what we can do as an industry to continue to drive progress is how we can really get together and really focus on what we each do well and then work together to drive those priorities and advance the industry. And really, Bruce Power, we see ourselves as that core, safe, reliable irradiator, providing irradiation services to Nordion for cobalt and now our lutetium program as well. So as I mentioned, we have been producing cobalt at Bruce Power for about 40 years now. And I mentioned earlier on the Bruce A and the Bruce B construct. So we do have the 8 units on site, and we produce Cobalt-60 in 4 of our 8 reactors. And those are what we call units 5 through 8, which is our Bruce B station. The way that's done on our site is we use what are called adjuster rods that are designed in our reactor design. And the Cobalt-59, which we source through Nordion with our partnership with them, is provided to us. Those Cobalt-59 rods are inserted into the proximity of the core while we have what we call planned outages for the reactors. As many know, we fuel our reactors online, but we do take those reactors offline every couple of years for planned maintenance outages. And the Cobalt-59 is inserted into the core during that time. It irradiates for a couple of years, and then in the subsequent planned outage, the irradiated Cobalt-60 is removed from the core. And what you see here is our secondary radiated fuel bay, which is where we store our spent fuel from the reactors. This is where the cobalt, which you can see near the top of the picture, the blue strings hanging there, is stored, housed, processed on our site for transportation, and then eventually shipped to the Nordion facility for further processing. So we began producing cobalt in 1986. A couple milestones for us in 2019. We created our first successful high specific activity cobalt, which I know Richard will talk more about the benefits of that, but it allows us to provide that high specific activity cobalt to Nordion. And then in addition to the 40 years of operation, we do have a couple key milestones coming up or historic events. So early this year in our what we call 2681, but that's the Unit 8 outage for 2026. We did complete our first harvest of heavy adjuster rods, which is a project we worked on with Nordion to figure out a way to get more yield or more cobalt from each harvest. And then at the end of this year, for the first time for us, based on the amount of cobalt that we're making for Nordion and our outage schedule, we will actually have 2 campaigns worth of cobalt stored in our secondary rated fuel bay portions of for a period of time. So really why we highlight this as a historic harvest is it just reinforces not only the importance, but the value that we find from working closely with our partners such as Nordion and even industry partners like OPG to understand OPEX and how to best perform these campaigns. Because at the end of the day, it's in everybody's best interest that we safely execute these campaigns and can provide as much cobalt as we can to Nordion to make sure that it gets out to the community. So a couple key highlights coming up for us. In addition to the 40 years of safe and reliable production we've had of cobalt from our site. And just one interesting fact, I don't know how many people on the call would remember, but not many people may know. If you recall, in 2003, we had a blackout in Ontario. And one of the first units to come back online was one of our Bruce B units. And our ability to bring that unit back on time quickly was closely tied to the cobalt rods that we had in core and our ability to slightly remove them from core to affect the radiation and the reactivity in the core, which allowed us to keep that unit at a state where we could quickly bring it back online and was one of the first units to come back online to start restoring power to the province. So it's a neat little tie with cobalt and how it played into Bruce Power's role in restoring power to the province back in that outage in 2003, for those that do remember it. The second area I wanted to talk about is lutetium-177, and although not tied to cobalt production, it is important for us to highlight the focus, the attention, the priority that Bruce Power places on continuing to drive advancements in medical isotope community, but also to secure supply. I mentioned electricity as our main business, it's our main focus. But the benefits of medical isotopes beyond revenue, I think, are, you can't question them. And it's important to us as a company that we continue to make sure that we can maintain our role as a safe, reliable supplier. So a few years ago now, it's probably 6 years ago, we looked at our cobalt process and recognized the value that we have through the neutrons available in our reactors. But we realized that we have some opportunity that we're missing with short-lived isotopes, especially with the decommissioning of the NRU. Whereas I mentioned, we harvest cobalt during planned outages. So our team was challenged to determine a way that we could begin to irradiate shorter-lived isotopes while our reactor units were online. And through the next couple of years, that was kind of the birth of our lutetium production isotope production system. So that unit is actually installed in what we call Unit 7, which is another unit at Bruce B. And through that system, we're able to irradiate lutetium-177 while the reactors are online without any reductions in power on a weekly or bi-weekly basis. So this was significant for us for two reasons. Not only did it allow us to determine a way to create shorter-lived medical isotopes without taking the reactors offline or reducing power, so maintaining reliability of supply to the province, but it also enabled us, and you see some of the details here, it was the first time we were able to set up a partnership with our local Indigenous community called the Saugeen and Ojibwe Nation. So between Isogen, which is a partnership of Framatome and Kinetrix, and the Saugeen and Ojibwe Nation and ourselves, we formed a partnership called Gamzu Aminakazwin, which means fighting cancer. And the Saugeen and Ojibwe Nation are actually a partner in that lutetium isotope production business and the system that we installed in Unit 7, and that's grown over time as we continue to expand the isotope system on site. So it really demonstrated Bruce Power's desire to maintain its position as a leader in innovation in the medical isotope space, and our commitment to continuing to make investments on enhancing our isotope program. So really that, in a nutshell, is Bruce Power's current position on what we do to support the supply of Cobalt-60 from Canada using our 8 reactors that we have on our site for cobalt production. What I wanted to spend a few minutes now on is sort of bigger picture for Bruce Power, what we're doing over the next few decades for our site, but also what that means for Cobalt-60 supply from the Bruce Power site as well. So I mentioned earlier on, Bruce Power is currently in the midst of a 13-year site refurbishment program, which extends the life of our site out to the 2060s. So if I take a step back to about 2011 timeframe when I joined Bruce Power, we were looking at shutting down the 4 units on our site at the Bruce B station, units 6 to 8, in 2018 to 2023, which was the current end of life for those units. And what that would have also meant, not only would we have been a 4-unit site for electricity production, it also would happen to be the 4 units that we were producing Cobalt-60 in. And through a lot of planning and good work between the company and the province at the time, we entered into a long-term energy deal with the province of Ontario, which allowed us to go ahead with this major component replacement program. And what that means is we're refurbishing 6 of our 8 units on site between now and 2034, which extends the life of those units out to the 2060s. And it's really an overhaul of the entire reactor itself and all the secondary components as well to extend the life of those reactors. And the benefit for us is it also extends the life of our cobalt production capabilities, because you'll see there units 5, 6, 7, and 8 are the ones at the Bruce B station, which we currently make cobalt in. So beginning in 2020, we refurbished Unit 6, and that was successfully completed on time and on budget, and allows us to continue to produce cobalt in that unit. As of 3 weeks ago, we completed our refurbishment in Unit 3, ongoing in Unit 4, and we have what we call breaker open, or the beginning of the Unit 5 MCR campaign, major component replacement campaign later on in this year. So great news for us that these refurbishments are progressing as planned, with Unit 3 actually coming in better than budget and better than schedule, but reinforcing our ability to execute these refurbishments and also bolstering our supply of cobalt through these 4 units out to the 2060s. So great news for us to continue to produce electricity, but also reinforcing our role not only as a reliable supplier, but a long-term supplier for Cobalt-60. And then finally, and probably one of the most exciting topics we have on site right now, is our Bruce C project. So in 2023, Bruce Power was given approval by the provincial government to do what's called an impact assessment to look at the construction of new reactors on our site. And essentially, we were given the approval to do an impact assessment of up to 4,800 megawatts of additional generation from our site, which, to put in perspective, I mentioned earlier, we currently produce about 6,300 megawatts, so 60% or so of additional output from the site. So that's what we refer to as the Bruce C project. I mentioned our stations are referred to as Bruce A and Bruce B now, so Bruce C would theoretically be that 3rd station on our site. So where we are right now with that is we're going through a federal process, which is called an impact assessment. That lasts about 4 years, and there's various phases to that process. Currently, we're in what we call the planning phase, and on track to submit an impact statement later on in 2026, which would ultimately bring us to get a decision from the federal government in 2028 to give us the license to prepare site and begin the build for Bruce C. In parallel to that process, though, and why it's important for the cobalt conversation, is we're also undergoing what we call a technology evaluation. So within our impact assessment, we're assessing up to 6 technologies, two primary technologies of the 6, but still assessing 6 to determine the overall cumulative impacts. But 2 of those technologies primarily, based on the size of what we see the project of up to 4,800 megawatts, are large reactors. And we operate CANDU reactors now on our site, and with the ability to operate up to 4,800 megawatts, one of the potential technologies that we could select based on the overall evaluation would be a CANDU technology. But we also have reactors like the AP1000 and the Westinghouse technology now looking to produce cobalt as well. So where we see as an exciting fit is not only does it mean for Bruce Power an additional 4,800 megawatts of electricity production from the site beginning in the 2030s, which would then let our site run out to the 2100s as a producing site and an operating reactor. But a high likelihood that it means that Bruce Power can add to our mix in the supply of Cobalt-60 through the construction and operation of these new reactors. So when we look at the 8 units of operation that we have on site and our sustained production of Cobalt-60 for the last 4 decades, the refurbishments that we're doing now to extend the life of our units out to the 2060s and subsequently extend our cobalt production, and now the potential for a Bruce C project and the opportunity to build new reactors in the province that can also continue to add to our contribution to the cobalt supply chain. It's really exciting for Bruce Power to be in that position, looking at long-term growth and sustainability, but also something we're very proud of to continue to be able to play a role in providing secure, reliable Cobalt-60 and doing that safely as well for the community. So lots of that on the way for Bruce Power, but still happy to be able to tie it all back to the value that we put into our contributor as a Cobalt-60 producer, and really reinforcing the importance of, we'll hear for OPG on the call, Westinghouse and Nordion, but as an industry, we don't do this alone. We do this together, and it's our ability to work together to really understand what's important and then drive for those objectives so that we continue to make advancements as a team. And Martin, that's it for me for the Bruce Power update, so I'll turn it over to you.
Thank you, Chad. Yeah, that's all great to hear. So more cobalt from existing reactors, work ongoing to extend the working life of those reactors until 2060s, and then the big opportunity is perhaps Bruce C. Chad, is there any indication that you can talk about in terms of timing for Bruce C?
Yeah, I think the way to look at the timing is the timing of the federal process right now with the impact assessment. One of the things I mentioned was the technology evaluation, and with those technologies, they have varying timelines to some degree for execution. But really the certainty that we have right now is we're leading up to that license to prepare site in 2028. But I think if we step back and look big picture, the overall timelines for new builds in the province probably put us in the mid to late 2030s to begin production of reactors, providing that the processes that we go through all go through to plan.
Okay. Thank you, Chad. But certainly an opportunity for another step change in cobalt production. Thank you, Chad. Excellent presentation. I'd like to introduce our second speaker now is Kris Horne from OPG. Kris is Director of Commercial Isotopes at OPG, and he's going to update us on their work, not only to secure existing production, but also to bring Cobalt-60 production to some new reactors. So, Kris, over to you.
All right, thanks, Martin. And just confirm you can see my screen as well?
Yes, we can.
Perfect. All right, morning and afternoon, depending on where you are. I'm excited to talk about OPG in terms of its cobalt and isotope production. Chad did a great job in terms of talking about the CANDU technology and the advantages it has. So I'll try to minimize the amount of duplication just in terms of a lot of the similarities between our 2 sites. All right, so we'll go through a bit of who is OPG and some of the competitive advantage just in terms of the CANDU technology. I'll look at each of the specific sites as well, and then in terms of future growth, where we're looking to go, similar to what Chad talked about as well. So OPG is, the largest producer of electricity in Ontario and one of the largest clean energy producers in Canada. We produce 18,000 megawatts of power, largely through a mix of hydroelectric, thermal, nuclear, and solar. What I'll be focusing on for this presentation is our two nuclear assets, which are the Darlington site, which is about 30 minutes east of Toronto, and the Pickering site, which is about 15 minutes east of Toronto as well. I wanted to also point out our subsidiaries, particularly Laurentis Energy Partners, who helps with our isotope program, delivering commercial isotopes to Canada, Ontario, and around the world as well. So just some very similar trend to what Chad was mentioning. You see that a lot in Ontario, our province. There's a lot of growth in terms of energy demand. And what that's bringing is a lot of growth in terms of nuclear projects. So, and we've taken an approach of a walk before we run, very similar to what Bruce Power is doing. We've recently completed our Darlington refurbishment earlier this year. That was under budget, ahead of schedule as well. So all 4 Darlington units are completely refurbished. And we're moving into our Pickering refurbishment, which is going to start at the end of this year. So Pickering site has 8 nuclear reactors. 4 of them are taken offline and going to be decommissioned, which is our A side, but our Pickering B side, which has 4 units, approximately 650 megawatts, are all planned for simultaneous refurbishment starting at the end of this year. So we'll have one last harvest from each of the 3 sites that we have at Pickering before we move into that refurbishment project. And OPG is also working on a new nuclear project. We're currently building the first small modular reactor in the G7. So that's at the Darlington site, with a plan to build 3 additional ones by 2036. So with the first unit being online in 2030. And then similar to Bruce Power, we're also looking at large nuclear development, which we'll get into a bit later in the process. And then from our SMR program, we're also looking at international SMR programs. That's one of our other new subsidiaries. Origin is looking at small modular reactor development in other countries, particularly Europe is an area region that's interested in small modular reactors now. So we're advancing a lot of projects, particularly in Poland, Estonia, but also looking at other jurisdictions as well. And then finally, we're just looking at Gen 4 SMRs in terms of industry, remote communities, potentially development in the future. I'll touch a bit on this. Chad kind of touched on a lot of it, but why is CANDU an advantage in terms of isotope production? For those who aren't aware, CANDU uses deuterium oxide or heavy water as our moderator. We use natural uranium as the fuel, so no enriched uranium is part of our reactor design. And the low reactor operating temperature and pressure are one of the key advantages in terms of how we're able to produce isotopes online. We also have a very uniform flux across our reactors, which is helpful in terms of making sure consistency in terms of our supply and delivery in terms of continuous irradiation. And then, as Chad mentioned, we also have refueling, which is online, which allows for harvesting online, and then also for cobalt harvesting on outage durations, which are usually 24 to 36 months. So these are the isotopes that OPG and our subsidiary Laurentis produce. So you see cobalt there at the top left. We also have byproducts from the CANDU operations that we're looking in terms of helping in terms of distribution to different industries. Tritium being the one big key one, which is largely used in radioluminescence, but starting to see huge growth in terms of fusion energy projects. We also have D2O. At one point, OPG had the largest heavy water production in the world, and we do have a limited inventory that we've kept for our new nuclear projects. but we also do heavy water detritiation services for CANDU customers. We're also started a carbon-14 project, which is used for radio labeling. And then our Laurentis side, we've used our reactor to help produce molybdenum-99, which we're partnering with PWXT to help with the North American supply of Moly Tech. We've also recently commissioned for yttrium-90, which is used in liver cancer in partnership with Boston Scientific, and lutetium-177. As Chad mentioned, we've also just commissioned in partnership with BWXT. And we also have helium-3, which is a decay product from tritium that's used a lot in quantum computing, neutron research, and border security. So the main focus of this presentation is obviously cobalt. Richard will get a bit more into what the cobalt is used for, but as mentioned before, it's largely used in sterilization of medical equipment, and then in terms of food product irradiation to ensure that the harmful bacteria is treated before distribution. So I'll focus first on Darlington. So as mentioned, it's one of the top performing nuclear stations in the world. We've gotten 10 101 rewards in a row, which is a significant achievement in terms of performance. We have 4 units that are approximately 850 each for 3,512 megawatts. And it's been safely and reliably operating for over 30 years. And with the refurbishment just completed, we'll be able to operate for another 30 years. And as mentioned, so it was completed 4 months early and $150 million under budget. And anyone who's aware of nuclear projects, completing a project to this scale and scope early and under budget is a significant achievement for the industry. A lot of nuclear projects have obviously gone way over budget, way over schedule. So we're extremely proud milestone for completing the Darlington refurbishment. And as you mentioned down at the bottom, like I think there was 20,000 lessons learned from the first unit that we took over to subsequent units and are now taking over approximately 9,000 lessons learned to apply to our Pickering refurbishment project, which I mentioned earlier. So with the Darlington Cobalt program, so as part of that refurbishment, we did include cobalt as a major part of that refurbishment program. So we'll have cobalt on all 4 units at Darlington. With our first harvest is planned for 2028 out of Unit 1. So this was done in a lot of collaboration with Bruce Power, our partners at BWXT and Nordion as well, just in terms of ensuring all the lessons learned from cobalt production in CANDU was applied to these 4 units. So, this is a huge milestone in terms of cobalt supply, just in terms of these are 4 brand new units expected to, provide enough sterilization from each unit for 6 billion syringes every 36 months. So a significant milestone and introduction of new cobalt supply into the marketplace by introducing it at Darlington. Shift now to Pickering, which does produce cobalt. It's produced it for the last 50 years. So what we're planning to do with Pickering is we have 3 units that we're going to harvest at the end of the year prior to going into our refurbishment. Our refurbishment's going to start in early next year, and then be back online in the mid-2030s is the target, which will allow another 30 years of operating life for the Pickering nuclear station. So again, this was a decision made recently in recent years. Originally, Pickering was going to close and be decommissioned, but just based on electricity demand and the introduction of keeping Isotopes growth going, the decision was made by the government to proceed with the new Pickering refurbishment, which is great news for the cobalt industry, but also residents of Ontario, just in terms of that decision. And what Pickering Cobalt looks like, so we have 3 units that do it. So it's units 6, 7, and 8 at Pickering. And what we've seen lately going into our refurbishment is we're seeing actually world record harvest. So it just shows the amount of OPEX and industry sharing between sites that the best years of cobalt production and from Pickering have been its last years going into a refurbishment. So, which has really been a testament to the maintenance programs, the operations staff at Pickering, that we've been able to keep the units online, very low forced loss rate to ensure that we're getting electricity to the province of Ontario reliably, but we're also able to ensure that we have high activity harvest for the cobalt industry. Very similar to Bruce Power, we're also looking at additional large nuclear projects east of Toronto. So this is about an hour, I want to say, east of Toronto at the Wesleyville site. Originally, it was earmarked for diesel way back in the 80s. It ended up not being commissioned. So the site is sat vacant, very similar to Bruce Power. We're currently in our impact assessment phase where we're reviewing, working with the governments, the local municipality, Indigenous in terms of ensuring all the impact assessment tasks are complete. But we're looking at up to 8 large nuclear reactors for this particular site. The impact assessment's been updated for that. So it could be an additional 8,000 megawatts depending on what technologies is selected. Similar to Bruce Power, we looked at a number of technologies, largely whittled down to 2 preferred technologies, which is the CANDU, which would be a similar design to Darlington or the AP1000. And as Chad mentioned, they're both technically capable of producing Cobalt-60, which is again great news in terms of the supply for Ontario and for the world. And we're working with our partners at Nordion in terms of discussion, which could help with cobalt production for our Wesleyville site as well. So just in summary, I think between both Chad and myself, like you see that the growth in Ontario in particular in terms of nuclear and in supply of isotopes and electricity is certainly growing. And we work very well together in terms of collaboration, partnerships, and the community within Ontario to grow that market. That's all I got, Martin. Thanks.
Yeah, thanks, Kris. Another great, very positive presentation. Lots of developments. 4 new cobalt production units at Darlington, the extension of the operations at Pickering, and what sounds like a huge potential longer-term opportunity in Wesleyville. So I hope that gives some comfort to the gamma irradiation and healthcare industries about the long-term future supply of cobalt. Just a reminder that the Q&A tab is open. If you have any questions, then please type them in the Q&A and we'll get to them at the end of the presentations today. Okay, so our third presentation is from Kris Paserba at Westinghouse. He's Solutions Manager for Radioisotope Production Technologies. And just to be clear, Westinghouse is not an operator of reactors, but it's and you'll correct me if I'm wrong, Kris, a reactor design and technology company. And you've been working with various partners to introduce Cobalt-60 production in a new reactor platform, the PWRs, and also in a new location in the US. So I guess I heard about this for the first time at least 7 or 8 years ago, and it was a concept and a theory. So I'm excited to hear how this has developed over recent years. So Kris, over to you.
Thank you, Martin. It's been a long time coming. And Martin, can you confirm sound check and screen check?
You're all good. Thank you.
Okay. Thank you very much. Hey, and thanks to Chad and Kris as well for the perspectives on the role that their CANDU reactors play in today's Cobalt-60 supply. I thought it was interesting to really learn about the work underway to expand that capacity. We'll be talking about what we're doing in the US using, like Martin said, a new reactor platform to really help contribute to that supply capacity. So I'll echo what Kris just said a second ago. Good morning, good afternoon, good evening to everyone in attendance. My name, just repeating what Martin mentioned a second ago, it's Kris Paserba. I work for Westinghouse as a product manager, really overseeing the development of radioisotope production technologies. Our main focus right now is on Cobalt-60. At some point in the future, we may start looking at technologies for additional isotope production, but right now we're very passionate about this program we'll be talking about today. I think you can hear it in the voices of Chad and Kris. You know, again, we love the passion that the CANDUs, that the Canadian reactor units have always put forward in the production of radioisotopes, specifically cobalt in this case. This program has really captured the attention, the interest, the passion of a lot of people in Westinghouse. So it's been a long program. Martin mentioned, 7 or 8 years ago. I think we're finally in a position to be able to announce some really nice developments that we'll get into in a few minutes. And I guess just to sum up where we're going with this presentation today, I want to build on the discussion that Chad and Kris started off with, and just introduce this additional supply pathway. And I want to make sure to focus on the fact that this is a complementary effort to bring Cobalt-60 production into the commercial pressurized water reactor, or the PWR fleet. So with that, I'm going to start off by giving just a quick primer on Westinghouse. I'll let Richard talk about Nordion. Westinghouse, as Martin indicated, really our bread and butter is the design of reactors, the maintenance of reactors, making sure that they continuously produce safe, reliable, clean electricity. Westinghouse is headquartered in Cranberry Township, PA. It's a little suburb just north of Pittsburgh. We are the world's leading supplier of safe, innovative, clean nuclear technology. For those of you that aren't aware, we designed the first commercial PWR in 1957 in Shippingport, Pennsylvania. Our technology is the basis for about half of the nuclear plants in operation. Again, bread and butter is really PWRs. Currently, and this is really where we're looking for cobalt supply coming out of the US, we supply fuel to over 75% of the US fleet of 64 PWRs. We really do it all. We're a vertically integrated fuel vendor. We develop, we manufacture, we do engineering design, safety analysis, licensing, testing. We have a number of facilities that are strictly designed for testing of nuclear fuel and materials performance. So we really do it all in terms of fueling the reactors, in terms of maintaining the reactors. And, especially as these reactors start to look to go, Chad was mentioning the refurbishment program. A lot of the US fleet is looking to go to, an additional 20 years, 40 years, 80 years of life. So continuously being able to maintain that fleet is going to become very important. It is very important when you talk about cobalt production as well, developing technology, licensing technology. It's critical that we have reactors that are going to remain up and running and functional and operational, so that we can actually be producing cobalt for a number of years. Okay, so as we heard earlier, I think everybody knows demand for Cobalt-60 continues to grow. And with that comes an increase, really an increasing focus on supply security, long-term availability of cobalt. And many of you know this, but I think really one of the more interesting dynamics in the cobalt market is the fact that the US consumes about 50% of the world's Cobalt-60 supply, but today we don't produce any of it domestically. And at the same time, and you heard me say this just on the previous slide, the US operates the largest fleet of commercial nuclear reactors in the world, PWRs primarily. We have some BWRs sprinkled in as well. But this was really the question that was asked 7 or 8 years ago, mainly by Nordion. A few folks at Westinghouse kind of got together and we said, can we expand the existing supply base, utilizing existing nuclear infrastructure that's in place, utilizing infrastructure that really is, back to I mentioned before, 64 PWRs. It's a scalable base. So develop technology for one, have the ability to scale across multiple units. And that's really what our program is intended to do. It's to introduce Cobalt-60 production into Westinghouse fueled PWRs to create a new source of supply. But again, I want to emphasize this, it's a complementary source of supply. So complementary to the existing CANDU fleet. It's not about replacing existing production. It's about really diversifying and strengthening the supply chain that already exists. So I'll just echo again, building on the strong foundation that already exists with the CANDU-based production platform. And you'll hear from Richard on this in a little bit, but it's really being done through a strong partnership between Westinghouse and Nordion, and then ultimately our participating PWR utilities in the United States. So I always like to highlight this table because in theory, if you step back and think about production, Cobalt-60 production, you really step back and look at it at a high level, you would think that producing Cobalt-60 in a PWR might seem relatively straightforward. It's been produced in CANDUs for decades. You heard from Chad and Kris talk about their production programs. The production pathway, I would say, is relatively simple. But when you look at the differences between the CANDU fleet, the Russian-style, Chernobyl-style reactors, the RBMKs, and then what we're looking to do in PWRs, developing PWR technology really turned out to be, I would say, a bigger challenge than many of us expected. And that's because we were introducing cobalt production into an entirely different reactor environment. And you can see that by what I highlighted there in the red box. If you look historically, let's just take, for example, the first column. Cobalt-60 production has occurred primarily at what I would say low temperature and low pressure. So for example, in CANDUs, Cobalt-60 targets are irradiated in heavy water moderator that is around 60 to 70 degrees Celsius and near atmospheric pressure. And if you move to the right, to the last column, if you compare that to a commercial PWR, you see that the reactors operate under really different conditions. The PWRs, I would say, are significantly more demanding in terms of the conditions. You're looking at higher temperatures, higher pressures, likely longer irradiation durations. And that's really the key distinction, I think, in our program. In addition, the targets that we're going to be irradiating are likely to remain in the reactor for multiple operating cycles, whether it's 3 18-month cycles in the US, perhaps 2 or more 24-month cycles. A lot of our PWR fleet is starting to transition to 24-month cycles, but you're looking at the order of several years of irradiation time. So it's not just simply temperature and it's not just simply pressure. We're looking at long-term exposure to neutron irradiation and everything that comes along with the long temperature, long pressure durations. You got corrosion concerns, oxidation, material growth, really the full range of what you would expect to see of in-reactor effects that had to be evaluated. So back to my earlier point, this isn't really just a matter of adapting an existing approach that's been used in CANDUs and RBMKs for decades and adapting that to the PWR fleet. This is really about introducing cobalt production into an operating environment that's fundamentally different, than where it's been traditionally produced. And solving that challenge, back to what I said before, it's what's really captured the imaginations of a lot of people in Westinghouse. It's created an opportunity for us. And I'll say the opportunity is really about enabling Cobalt-60 production in the largest operating reactor fleet in the world. And again, adding a new complementary source of supply. Now, I'm not going to go through, there's a lot of information in this slide, but I wanted to focus first of all on the technology, which you see on the left. I'll say again, it looks relatively simple. So what you see on the left is what we're calling the cobalt burnable absorber, or the COBA. It's designed for use in Westinghouse PWR fuel assemblies. It's what we call a fuel assembly insert. So it actually goes into a fuel assembly. It's not integral to the fuel assembly, but it gets inserted into a Westinghouse PWR fuel assembly. And it contains cobalt targets that are then irradiated in a reactor core and converted into Cobalt-60. And what you see from the inset there, the design, I would say, is relatively straightforward. Each insert contains a series of rodlets. Each rodlet contains capsules. And each capsule, if you can see in the insert there, contains a number of cobalt target slugs. And back to what I said before, the COBA really functions as an insert rather than an integral fuel assembly component. That's different than the way it's been produced in the past in, for example, PWRs, which was tried roughly a decade or so ago. That design choice, it was intentional. It's also very important because it simplifies how our technology gets implemented and how it supports the overall supply chain. It simplifies installation. It simplifies harvesting. It simplifies transportation. And it really simplifies how we license this product within the US NRC. The real work, now again, I mentioned, it looks relatively simple. The real work is probably on the right side of the screen. Now, again, I'm not going to go through all of these, but what I want to highlight here is over the past 7 years, we've really tried to address all aspects of integrating cobalt production into commercial reactor operation. So you see over there everything from core design to safety to materials performance. The result of all this is a technology design not just to function, but back to what I said before, support reliable and consistent Cobalt-60 production over multiple operating cycles. Okay, and then just to wrap up, this is my last slide before I turn it over to Richard. Just want to highlight here that bringing this new technology online really required us to look across the full supply chain. So from development of the technology to licensing to manufacturing, installation, irradiation, and ultimately delivery into the commercial market. Back to what Martin said before, this program began in 2019, and it's really involved close collaboration with Westinghouse and Nordion. Now we have a utility signed up, PSEG, with a reactor unit called the Salem unit in New Jersey. The most important piece I want to highlight here, though, is that where we are today, we're entering a really probably the most important phase, the deployment phase. The first COBA targets are scheduled to be installed in the Salem reactor in fall of 2026. So we're almost getting to fall right now. We're talking about a few short months. And that means that cobalt production in PWRs, it will no longer be a concept. It's going to turn into an active advancing program. And we're really excited about that. And I would just say, so as you step back and you look at this alongside with the investments and the expansions that Chad and Kris talked about at Bruce and OPG, I'll just leave you with this. The key takeaway is really the fact that a new source of Cobalt-60 supply is being added. It's being added in the next few months. And this is a scalable technology that we really expect to grow over time alongside existing production. So Martin, with that, I will turn it back to you to introduce Richard. And I'll just say again, Richard's really been a huge driving force for this program. And back to what I mentioned before, the partnership between Westinghouse and Nordion has been really strong, and Richard's been the driving force behind that.
Thank you, Kris. Wow, it's an excellent update, and it's great to hear that this is no longer a concept anymore. I just got a couple of things that come to mind, and maybe a couple of questions for you. So you touched on your relationship with the reactor operator PSEG. I think that in itself is very exciting. You talked about some of the challenges. I guess they've all gone through NRC now, and they've all been addressed, and everybody's comfortable, right? Otherwise, I guess PSEG wouldn't have gone through the license process.
So good question there, Martin. We are actually right now nearing the end of the licensing process with the US NRC. So our target is to have our license, actually I should say PSEG's license in their hands by the September timeframe, which will allow us to actually insert targets into the reactor at their refueling outage, which starts in October. So it's a tight timeline, but we have been moving through the NRC review process very well with their staff. They've been doing a nice job of directing questions to us. Our team has been doing a nice job of addressing questions and concerns and challenges raised by the staff.
Great. I guess, and I'm sure we'll get some updates in 3 or 4 months' time when those targets are installed. So that's great news.
Yes.
Just maybe you could just summarize what makes the PWR fleet particularly attractive.
That's a good question. So, again, we know Cobalt-60 is already being produced today in other reactors, CANDUs, et cetera. The commercial PWR fleet, in my opinion, changes the game in terms of scale and reliability. What I think makes the PWR fleet so attractive is that you're working with, again, it's volume, right? A large number of high capacity reactors. They work on very predictable cycles. So you can, in theory, produce Cobalt-60 consistently and in commercial scale volumes. And then, on top of that, the infrastructure is there. You got fuel handling systems, outage schedules, well-established regulatory processes. So integrating Cobalt targets into that, what I would call routine refueling work without major disruption, that's the goal of what we're doing. And again, I think once you do that, then you have a scalable supply that can really help to diversify the supply.
And I guess that's not limited to the US, is it? I guess there's other.
It's not.
Yeah. Okay.
No.
Kris, I think I got lots of questions, Kris, but I think in the interest of time, I'm going to move over to Richard now. So, Richard Wiens of Nordion, you're Director of Business Development and Strategic Supply at Nordion. You're a well-known face within the radiation processing industry, so I don't think you need too much introduction. It's going to be the final presentation or the final sort of discussion before we move on to the Q&A. And Richard, I think you're just going to kind of wrap up for us and summarize the impact of all of these changes and talk about some of the other work that Nordion's doing to secure this supply chain. Richard, over to you.
Sure. Thanks, Martin. So my job's easy because I'm basically just going to and start with sort of the importance of Cobalt-60. We heard about 30% of single-use medical devices, 40% in the US, which equates to about 16 billion devices annually. It's by far and away the predominant radiation sterilization modality, so super important. Not necessarily directly relevant for the folks on the call, but you heard Chad talk about high specific activity cobalt, HSA cobalt, pellet cobalt, known by many different names. That's used for cancer treatment, and Bruce Power single-handedly produces enough to supply the world. So super important there. The second thing I would say in summary is you've seen the broad support in Canada and the US, particularly for nuclear as a base load energy source. So I think this is really important because that hasn't always been the case. And now we have this situation where people are starting to recognize that nuclear is necessary as base load if we're ever going to meet our climate change goals. There's a whole other series of webinars we could do on nuclear as part of the solution for climate change, meeting our climate change goals. So I think that's super important, evidenced by the $25 billion or so that will be spent in Canada for refurbishment of the 6 units at Bruce and the 4 units that have been done at Darlington, as well as up to 12 new large-scale units. Again, good news there is the top 2 technology choices appear to be CANDU, which has been producing cobalt for years and years and years, and the Westinghouse AP1000, which is a close relative of the reactors that we are currently using for implementation of cobalt production in the US. So good sort of translatability, if you want, in terms of being able to use that technology. In the US, there was a program announced, an $80 billion investment and potential expansion of AP1000s in the US as well. So again, new capability for cobalt production. So sort of the long and the short of all that is that we are currently meeting the cobalt demand, and with demand growth, we are preparing ourselves to be able to meet demand into the future because we have this longevity that I've talked about. I think beyond that, Nordion has made some additional investments around the edges. So of course, it's important to produce cobalt in nuclear reactors. It's almost equally important to be able to turn it into finished sources and ship it around the world. And we've made investments in both of those areas. So things like expansion of our hot cell capability here in Ottawa, as well as continuing and ongoing large-scale capital investment in transport packages, so the shipping containers, specialized shipping containers that we use for transporting this around the world. And then the last thing I would say is to talk about the importance of the partnership. So all 3 of these companies, Bruce Power, Ontario Power Generation, and Westinghouse, have been fantastic partners to work with. Cobalt and isotope production is a very, very small part of what they do from a revenue standpoint. As you can imagine, these are multi-billion-dollar entities. They sell electricity for a living, yet cobalt and isotopes more broadly take a kind of an outsized position, I would say, in the importance of their corporate objectives. It's got visibility all the way to the top. They really, really focus on doing a great job and getting us cobalt when we need it. I did some simple math the other day and calculated that we have about 400 reactor years of operational experience. You'll hear people in the nuclear space talk about operational experience, or OPEX. They've been frankly sharing that OPEX, both Bruce Power and OPG, with the CANDUs, but equally with Westinghouse and the PWRs. So that's been fantastic, and just great partners to work with. So with that, Martin, I will turn it back to you, and hopefully there's a couple of questions.
Yeah, thank you, Richard. Great summary. There's one question, and I think then in the interest of time, we need to end the webinar. And it's a question for Kris from Westinghouse. Kris, looking ahead 5 or 10 years, where do you see this? Where do you see you being? What would success look like for you and Westinghouse and the operators?
No, I like that question, Martin. We talk about that quite a bit in Westinghouse. We talk about it with Nordion. I would say success would really mean that this has become, what would you say, a normal scaled part of how the nuclear fleet operates, the PWR nuclear fleet operates. You'd see multiple reactors across different operators routinely producing Cobalt-60 using standardized approaches, back to what we said before, in place policies, procedures. The program would be making a noticeable contribution to supply. Again, back to what we said before, kind of complementing the supply from CANDUs. It'd be fully integrated into outage planning, plant operations, and providing a nice steady revenue stream. I mean, it's still a little bit of a side hustle for the utilities, but it's still a nice steady revenue stream that can strengthen the economics of our nuclear plants. They're always looking for ways to become a little bit more economically competitive. So I think that's where we're looking 5 to 10 years out.
Yeah, thanks, Kris. Yeah, and it's not just about economics, also, is it? It's about, I mean, Bruce and OPG have I think taken advantage of the the benefits that Cobalt-60 and the other isotopes that they produce. The sort of wider benefit that isotope production brings. Got one other question that's just come in for you, and it's about the specific activity of the cobalt that comes out of PWRs. So I guess that's going to be initially, at least, primarily low specific activity. I don't know if that's Richard. You put your screen on. Do you want to answer that, or Kris?
Yeah, I can answer that. So the PWR specific activity will be similar to the light water graphite moderated reactors, the RBMKs in Russia, which is around the 70 to 80 curie per gram range, which is about half of what you get out of CANDUs. I would say the other end of that spectrum is that the CANDUs, as they go to longer and longer operating cycles, are producing hotter and hotter materials. And back to what I said about expanding production capacity through the addition of hot cells and things like that, part of the strength of the Nordion supply chain is we've got this diversity of specific activities so that we can mix hotter stuff from CANDUs with less hot stuff from PWRs and RBMKs, right? So yeah, the SA is lower than you would get from a CANDU, but again, back to Kris's point, scalability is key here, right? So we have many PWRs that we could expand this program to over time.
Thanks, Richard. Okay, well, look, we're over time. That's all the questions we have. I think we should close the webinar. I really want to thank our 4 presenters. Thank you for providing us with a lot of information, for lots of positive news. Chad, Kris, and Richard, thanks for being clear and for being transparent with us. We're going to call the webinar to a close now. If anybody in the audience has any further questions, then please send them to me and I'll be sure to contact our presenters. Thank you, everybody, for joining us today. We're going to put up a slide now, and it's just going to show some contact details of myself and Richard, and you'll see our IIA website address on there as well, so you can contact us about membership or about any other irradiation matters, and we'll try to help you. So with that, thank you again to everybody. A really useful discussion, and we will keep in touch with you all about future IIA webinars. Thank you. Bye-bye.